So looking at the law of cosines today, and we talked about law of sines on Friday. Law of sines allowed us to solve for an obtuse or an acute triangle. Law of cosines does that as well, but we only use law of cosines when we can't use law of sines. So at the most, you're going to use this one time per problem. Okay, after we find one thing using law of cosines, we switch back over to law of sines, which I think we feel decently comfortable with after Friday. Okay. Remember, to use law of sines, you need to know that combination. You need to have one pair where you know the angle and you know the opposite side to be able to use law of sines. You have to know one of them. In situations where we don't know one of them, that's where this comes in. So we're going to see two different cases here. We're going to see one where the pieces of information that we know forms a side angle side. So we know two sides and the included angle, but nothing else. The other one, which is a little harder, is the side case, where they tell us all three sides and we have to solve for the angle. Okay, so those are the two situations that we're going to look at. I covered up the law of cosine. Let's make sure we have that down. Okay, that law of cosine. The triangle is going to be the same as it always has been the last few sections. So we've got a squared is equal to b squared plus c squared minus 2bc cosine a. There's a lot there. This does need to be memorized. This is not on the orange sheet. We have to know. Highlight it, circle it, star it, whatever you got to do. So for Wednesday, you got to know. Something like that where you need to know it for the test. The first couple times you use it in the homework, feel free to use the notes and then try to get away from that, right? Try to remember it the next time and then double check and see if you got it. And then later on in the homework, you can say, all right, I know it, right? You don't have to check back anymore. Anyway, don't be so concerned about the letters, but we have to understand it, right? Because the letters could be different every single time. So what we need to make sure of, the angle that we're talking about, whether we know that angle or we're trying to solve for that angle, the side across from that angle is the one that's by itself over there. Okay, that's why it's a capital A here, a lowercase a here. Okay, that setup has to be there. Whatever angle we know or we are looking for, that's the cosine of that angle, and the opposite side has to go here. The other two sides are interchangeable. B and C could be switched, doesn't matter. But A has to be here if this is angle A. Okay, if this was angle B, then this would have to be the B. And then A and C would go here again. Okay? Yeah.
So you said, so it's like, it could be b squared plus b squared, and then to the minus 2bc, could it be cb?
It could. Yeah, it doesn't matter. As long as you got both of those in there, it doesn't matter if you switch in between. All right, so let's take a look at our first case here, the side angle side case. So here's our situation, and you can look, if you look in terms of law of sines, which we did on Friday, we don't have that combination. We don't have the angle and the opposite side that we know. So we can't use law of sines here. We wouldn't have enough to set it up. So we're going to use law of cosine. So we always start with the angle that we know or that we're looking for. We know a 34-degree angle. That means we're going to have cosine of 34 at the end. And then remember we said, whatever angle you have here, the opposite side needs to be by itself. That's what we're looking for here. We're looking for side B. So this is going to be just B squared. The other two sides, the 11 and the 14, are going to replace the stuff in here. So I'm looking at 11 squared plus 14 squared minus 2 times 11 times 14 cosine 34. I know the first couple times you see it, It can be a little confusing. Why did I put this here? Where did those numbers come from? All of that. But really, it's the angle that we know and the opposite side. And then the other two sides here and here. The squared stay, the -2 stays. And just plugging in what we have. Any questions right now on why something is where it is? Anything like that? Right? No, you good? Mike? Okay. So we're just trying to solve for B here. And we know everything else. There's no other variables. So this way it's pretty straightforward. I got B squared. If I want to get rid of that squared, what do I have to do? Square root, right? Opposite of squared is a square root. So we're going to square root both sides. We're just going to type that whole thing right in the calculator. And let the calculator do all the work right at the same time. Let's make sure we get the right thing. Type it in. Let's make sure. Text always do the same thing. If they didn't, see what they typed in differently. Yeah.
Oh, you forgot to snare the- Yeah. This is yours.
All right. So we type that all in. We hit equal. What do we end up with here? Brody? 7.9, about 7.9 for B. Couple things that, a couple mistakes I've seen so far today, right, with typing in. Because if you type it in wrong, a lot of times you'll get a domain error or syntax error or something like that, where it just won't give you an answer at all. Okay, things to look out for. Make sure this is a subtraction sign, not a negative sign. There is a difference on your calculator. Okay, so make sure you put a subtraction sign in there. Make sure we're squaring. Okay. Other than that, we should be all right.
Do you have to close the parentheses at the end?
You do not, because we're not doing anything after it. Right? If we wanted to, add 7 after it, then we would have to close it and do the +7. Okay. Anything else on that? Yeah, if we were doing something after, right, this opened one up, we would close it here and we would close it again to close that one. Okay, so once we have that 7.9, right, we get that 7.9. Now we have that connection, we have that combination, we can use law of sines now. Right, we can set up sine of 34 over 7.9 is equal to sine of A over 11, we can solve. Okay, so we're using law of cosines one time, and then after that, we're using law of sine. Now, this is where people are getting frustrated with big ideas. Because they're asking you to round, right? And we're going to put that answer in, and that answer is going to be absolutely 100% correct. But then we're going to use that answer to solve something else, and our answer is going to be 0.1 off. Because although they want you to round this answer, technically they want you to use 7.856 blah, blah, blah in your proportion when you're doing law of sines. Okay? So try not to get too frustrated with it. If you're 0.1 off, that's okay. On the test, if you're 0.1 off, I will see, hey, did you use that or did you use the actual? And I will give you it. Okay? But you will get a little frustrated tonight with that. So if you're 0.1 off, it's okay. All right, you can try a 0.1 up or 0.1 down, or talk to me if you're in class, still talk to me. And I'll tell you which way you got to go. Okay, or if you're way off, and then you gotta do it again. Okay. All right, any questions on this situation? Okay, so that was the side angle side situation. The other situation, which I told you is a little bit more involved here, is gonna be the side, side, side. Right, where they give us all three sides. And we need to solve for the angle. Why don't you sketch this triangle in your notes, just so you have it, so you know what we're looking at. It always helps to make more sense when we go back and look at it again. We have a picture to go with it. That's a C up top. Are you recording? Yes, I am.
Hello, future.
I hope you watch your. All right, anyway, so I'm gonna give you a hint here that I didn't give the other classes because we didn't realize it until fourth hour, okay? When you're doing this, solve for the obtuse angle, okay? Solve for the obtuse angle first. Okay, if you solve for one of the acute, that's fine, you're gonna get that right. But you go to do law of sines with an obtuse and it doesn't work out, okay? Solve for the obtuse angle first. Okay, so we're gonna solve for angle B. So I want you to put in all the information that you know into there, knowing that we're solving for angle B. So the letters don't match up, right? But we're solving for angle B. I want you to put in what you think. And then we'll make sure that you're right. Just plug stuff in. Plug stuff in where it should go into this equation. And then we'll talk about, did you put the stuff in the right spot? Remember, guys, don't get so caught up in the letters, right? Because the letters are going to be different every time. We got to understand the equation. The person around you has the same things in the same spots.
I also right away.
All right, hey, so most important part here is knowing which of those sides is gonna go by itself over here. What side is gonna go by itself over here? Alex, what side is gonna go by itself? 27. Because that's the side that's across from the angle we're looking for. Okay, so the 27 squared is gonna be by itself. Now the other two, we can fit in here. Cody?
So the angle is always gonna be on the right side.
Correct. It doesn't necessarily matter, right? But this is how I write it every time. And it's how you're gonna see it. Okay, so we put in the other ones. 12 and 20 could be switched, doesn't matter. Over there. Any questions on the setup of it? Okay, so now when we're solving, it's a little bit different because what we're solving for isn't over here anymore. It's buried all the way over here. We got to do some work before we can use the calculator. Okay, because this is buried, this cosine B, we've got this stuff added to it. I've got this multiplied by it. We got to get rid of that stuff first before we can actually solve for B. So I'm going to show you the way the book shows it, in the way that I would do it. And then we can talk about how, if you're unsure of that, what you could do differently. Okay? I'm gonna let the calculator do all the work. I'm just gonna rearrange stuff and then use the calculator at one time. Okay? So I know that I need to subtract the 12 squared, I need to subtract the 20 squared. I need to get those over to the other side. So I'm gonna say 27 squared minus 12 squared minus 20 squared. Right? I'm subtracting those over. That's gonna get me here. Right? You could simplify this if you wanted to. You could type that in the calculator, get a number, absolutely fine. You don't have to. Now I need to get rid of the rest of this stuff. And these three things, that -2, that 12, that 20, those are all multiplied into cosine B. What's the opposite of multiplication? Division. So I need to divide that on the other side. So I'm going to divide by -2 times 12 times 20. And when I divide by that, that's going to cancel out over here. So now I have cosine of B by itself is equal to this whole thing. What do I have to do to solve for an angle? Really?
Oh, I had it different, but
Okay, what's your other question?
how is it 12 and 20? Wouldn't it be a fraction?
The 12 and the 20 come from here and here.
But to find the cosine doesn't need the fraction. And
But it's not a right triangle, right?
oh,
So we can't think of it that way. Yeah. Yep.
Okay, but that's still a tangent.
But it's not a right triangle. So we can't think of it that way.
Well then,
That the original sine cosine tangent that we learned, the SOHCAHTOA, you cannot apply that to this. Okay?
yeah, but
There is no hypotenuse, there's no opposite, there's no adjacent. We cannot find that ratio.
wait, there's no hypotenuse.
There's no hypotenuse if it's not a right triangle.
Really?
Really. Hypotenuse is only in a right triangle.
I thought it was just the longest side.
Yeah, that's what
It's the longest side in a right triangle,
I
Why
thought it
can't it
was
just
the
be the
long.
longest
because
side?
that's not what it
I thought it
is.
was the side of across from the largest angle.
It's the side across from the 90. Has to be, every time. Boom, what do we have to do? Yeah, anytime you're looking for the angle, we have to do the inverse.
Where-
So we're gonna end up, guys, we're gonna end up doing the inverse cosine of this whole thing. The inverse cosine of that whole thing. And this is where we can type that all into the calculator if we type it incorrectly. Or you can simplify the top, simplify the bottom, and just put one fraction in there. Right? I want you to try to type the whole thing. I want you to try to type this whole thing into the calculator. Let's see if we can do it.
That's a lot.
Okay, it's a lot of stuff to type in, a lot of places to go wrong. Let's work on our calculator skills a little bit. Ready?
Okay, so we can't use SOHCAHTOA and stuff like that for this, but can we use these, like, I don't know, what do you call them?
Equations,
Okay,
formulas?
well, can you use these equations to find the, answers for
So you're saying will law of sines, law of cosine work in a right triangle? Yes.
So we don't necessarily need to know the other stuff. We just need to.
But this is harder than the other stuff. It's gonna make more sense to the other stuff. The reason why it's still gonna work in the 90 is because, like, if you're using this to find the cosine, if you do, or if you're trying to find that hypotenuse, right? If it's actually a right triangle, the cosine of 90 is equal
Oh, I
to
messed
0.
up.
It takes that one thing.
Oh, you did -2 to the
Hey, couple things to point out, just to be aware of, okay? You type in inverse cosine, it opens up a set of parentheses. You need to open up a second one to do the numerator. You need a second set of parentheses to get that numerator together. You need parentheses on the bottom to get the denominator together. Try it again.
That's what I.
Wait, they're two separate ones?
Yeah. Parentheses, so you would have 27 squared minus 12 squared minus 20 squared, parentheses, divided by, parentheses, -2 times 12 times
Is
20.
it in the 100?
It's obtuse, right? So that makes sense.
Let's go.
Oh, I need to negative.
As long as it's not greater than.
What do we round to?
Here's 10. Here's 10.
112.7.
Cheated, Randy?
Shows you how to do it. That's not me. It's naturally from black.
No more citizens.
Let's.
Okay,
Wait, Mr. Gadowski.
Yeah.
Is there any benefit of just typing it all into the?
no,
Okay, so
Nope.
don't do it because the other thing.
it's up to you. I mean, it's a little quicker, right? Other than typing this in, getting an answer, typing this in, getting an answer, then typing the fraction in, right? It's a little quicker to just type in cosine of all of that, if you're comfortable doing it. If you're not comfortable doing it, then type in this, get 185. Type in the -2 times 12 times 20, get -480, and then you're doing inverse cosine of that, you should get the same thing. Right? And there's a little less room for doubt with the parentheses and everything. So that's why I'm saying, if you try it this way and you get that syntax error, or you get something that doesn't make sense, then simplify top, simplify bottom, and type that in. Okay? What do we end up with for our angle? Brody?
112.7.
About 112.7. Okay? We get that 112.7, and then, right, we only use law of cosine once. Now we've got that pair. Now we can set up law of sines to find the other two angles, or at least one more angle, and then use triangle sum theorem. Okay? Yeah.
So in that case, like if you were finding the rest of the stuff, you have to use that really long decimal on big ideas to find that.
Yeah, I mean, you don't have to use the whole thing. Okay? The more decimal places you use, the more accurate, the more exact it's gonna be. So if you use 2, you're gonna get closer. You use 3, it's gonna be probably good enough, right? So if you wanna get that exact answer, then maybe use 3 places after the decimal when you're doing that next calculation.
But on the test, you don't represent.
On the test, you use this, I'm good with it, okay? You're gonna notice on big ideas, guys, once you find these two, you're gonna use triangle sum theorem to find the third, and it's gonna say it's wrong because of rounding. Okay, because of rounding, and again, it's frustrating, okay? But because of rounding, their 3 are not gonna add up to 180. Their 3 are gonna add up to 179.9 a couple times. Okay, so that's where, try it. If you think you're there, right, you're like, hey, I don't know why this doesn't work, then ask me, I'll tell you which way you gotta go. Okay. Any questions about this? Yeah,
Is there like a shortcut to know whether we're up, like to go up or down for the rounding?
no,
Really?
there isn't. No, unfortunately. I would try down first. That seems to be what most of them are. Yeah.
Isn't it if you round up, you want to go down?
If you're rounding,
Like I got 112.6, and then I round it up. Would you want to go down? Like
It would be
the decimal?
100, it was.
so then the next one would probably go down.
Yeah.
Yeah, yep, to even it out.
Think of it as not what I ever got this way.
Any other questions here? All right, guys, give it a shot. We'll talk about it tomorrow.
Sorry.